Good day, everyone. Today I'm going to present some preliminary results on the performance of ammonium nonanoate as a lentil desiccant. I'd like to acknowledge my co-authors from the Crop Imaging and Agronomy Lab at the University of Saskatchewan, Sean Cabno, Sydney Redicop, Keshav Singh, and Steve Shirtliff. So why the interest in alternative desiccants or harvest aids? There are consumer concerns in terms of pesticide residues in our food, and for various reasons, glyphosate has been particularly targeted. This has led to some lentil buyers specifying in their contracts that pre-harvest glyphosate cannot be applied. More recently, glufosinate is not recommended for pre-harvest use in lentil, even though it is registered. The reason for this is that some importing countries have lower MRLs for glufosinate than does Canada. So what is ammonium nonanoate? It is a mixture of ammonia and pelargonic acid. Pelargonic acid, which is circled in the diagram in the top right corner, is also known as nonanoic acid. It is a 9-carbon fatty acid, thus the name nonanoic. It is non-systemic, broad spectrum. It's a contact herbicide with no soil activity. It is sold under the trade name Axe in North America, and for ease of pronunciation, I will refer to its trade name for the rest of the presentation. In Canada, it is registered for pre-seed burn down, spot application, or shielded interrow application in field crops, pastures, and non-crop areas. A 13.5% volume-to-volume solution is recommended. However, this rate varies depending on weed size. In the United States, Axe is registered as a desiccant in potato and cotton. Desiccation rates in potato are 20 to 32.5% concentrations. The recommended carrier volumes are 200 liters per hectare, and the rate is dependent on foliage density. Axe is organic approved under OMRI, however its use is quite restricted with only farmstead maintenance and application to ornamental crops as approved uses. So let's get into the study. There were 8 treatments including an untreated check, 2 concentrations of Axe, 20%, and 33% volume to volume, glyphosate at 900 grams active, saflufenicil at 36 grams active, a tank mix of glyphosate and saflufenicil, glufosinate at 400 grams active, and diquat at 296 grams active, and appropriate adjuvants were included. The applications were made to CDC Maxim lentil, which is a small red lentil. They were applied in a carrier volume of 200 liters per hectare using nozzles that delivered a medium spray quality. In 2019, they were applied with a CO2 backpack sprayer, and in 2020, they were applied using our recently purchased Kincaid Cobra sprayer that was mounted on a Zern 550 high clearance tool carrier. This unit has 16 booms, so up to 16 products can be applied based on plot maps developed in ARM. Target application timing was when the lowermost pods were brown and rattled when shaken. However, we were probably a bit early in 2019 and a bit late in 2020 due to differing weather conditions. 2019 was quite wet in August and September, whereas terminal drought occurred in July and August of 2020. The mean plant moisture contents were 52% in 2019 and 45% in 2020, and these were our application dates. I want to show you these photos to show you how fast Axe works. These pictures were taken 3 hours after application, and you can see that significant necrosis has occurred in a short period of time. I'm going to now present some visual rating data from 2019. On the x-axis, we have the rating dates expressed as days after treatment, and percent visual dry down on the y-axis. This is the dry down curve of the untreated check over 24 days. Axe herbicide applied at 20% concentration. It achieved about 80% dry down after 3 days, whereas the 33% concentration achieved greater than 90% dry down after 3 days. Glyphosate alone reached greater than 90% dry down at 10 days after treatment, whereas saflufenicil alone only reached a maximum of about 80% dry down even after 24 days. The glyphosate and saflufenicil tank mix provided similar results as glyphosate alone. Glufosinate achieved 90% dry down 7 days after treatment, as did diquat. However, you can see that diquat was slightly faster acting than glufosinate at 3 days after treatment. I reduced the number of treatments presented in this slide as the trends were similar for most herbicides in both years. So the two concentrations of Axe resulted in similar curves with about 90% dry down achieved at 3 days after treatment. The glyphosate and saflufenicil treatment worked slightly better in 2020 than it did in 2019, with the tank mix reaching 90% dry down 10 to 14 days after application. Diquat reached 90% dry down at 7 to 10 days after treatment. I'm not going to show you the plant moisture data, just to say that it had a strong negative correlation with visual dry down ratings, so that just provides some validity to the ratings. I'm not presenting yield data either, but desiccation treatments did not affect yield in 2019. 2020 data is not available yet. I'm now going to move on to another part of this experiment. In the crop imaging lab, we are trying to utilize digital imaging for phenotyping, and part of that work involves quantifying herbicide efficacy and/or phytotoxicity. You've heard Steve talk about how well digital imagery worked in assessing faba bean tolerance to herbicides from a study that we did a couple of years ago. He likes to say that it works so well that he's going to fire me and buy more drones. In this study, we are trying to quantify desiccation dry down using hyperspectral imagery. This is being led by Keshav Singh, a postdoc in our lab, and I will be only presenting 2019 data. So this is the example of a spectral profile obtained from the hyperspectral imagery. The image is taken 3 days after treatment. So you can see that the spectral profile of 3 treatments differed from the untreated check in the red edge to near infrared regions. And these 3 treatments were diquat and the 2 rates of Axe. These herbicides demonstrated the highest visual dry down ratings as well. Partial least squares discriminant analysis, which is a form of multivariate analysis, was used to calculate desiccation response scores. And Euclidean distance was calculated to determine the distance from the treatment score. So, to explain what the Euclidean distance is, this is the untreated check score at 3 days after treatment. This is Axe herbicide applied at a 33% concentration 3 days after treatment, and the distance between those 2 points is the Euclidean distance. And when you graph these distances, you see the response curve trends are similar to the visual rating assessments that I presented earlier. So this is Axe at 20%, Axe at 33%, glyphosate and saflufenicil, glufosinate, and diquat. Keshav used these results to calculate a number of different vegetation indices, and he found that a maturity index correlated well with visual ratings, with significant R-square values ranging from 0.6 to 0.97. So, the results from the first year of this study indicates that hyperspectral imaging may have potential to be used as a means of objectively quantifying plant dry down from desiccant application. So to conclude, ammonium nonanoate was effective in desiccating lentil plant material, and it worked very quickly. It worked even a little quicker than diquat, but quite similar to diquat. However, it's not cost effective at the current price and rate structure. At the rates used and the retail price, the cost would be over $300 an acre or $700 a hectare. You notice that Axe still worked quite well at the 20% concentration, so there may be potential to use lower rates, but much lower rates would be required to make it economical. We also haven't looked at the effect of Axe herbicide on the grade of the lentil, so that would have to be investigated in further studies. And finally, there is potential to use hyperspectral imagery for quantifying plant dry down efficacy from desiccant application. I would like to end by acknowledging the Plant Phenotyping and Imaging Research Centre at the University of Saskatchewan, which is funded by the Canada First Research Excellence Fund and managed by the Global Institute for Food Security at the University of Saskatchewan. Thank you for listening, and I look forward to your questions.